Hello everyone. In this session, we are going to continue with our data structures in Apex series, and we are going to see two classical problems, that is two sum and three sum, and we'll be solving them using the Apex language. So let's not waste any time and straight away go to the problem and understand the problem statement. So I'm on the Leetcode screen. So this is the question, the two sum. So given an array of integers nums and an integer target, return indices of two numbers such that they add up to the target. So let's say we have this array 2, 7, 11, 15 and we are given a target of 9. So we have to find two elements which when we add those two elements we get the target value. So in this array we have nums, we have the 0th and the first element as 2 and 7, and if we add 2 and 7 we'll get target, that is 9. So the answer here is 0 and 1. Similarly, in the example number 2, if we'll add the first and the second element, 2 and 4, we'll get the target as 6. So let's solve this using binary search. So we have already solved this question earlier using the map solution. If you remember in the collections in the Apex series, we have solved this, but this time we will solve it using the binary search solution. So the binary search solution has a time complexity of big O of n log n, because we'll have to perform the sort here, and sorting in the worst case takes big O of n log n time complexity. So now let's understand what we are doing. Let me go to, I'm in my VS Code, and this is the solution which I have written for the two sum problem using binary search. So the first thing here is I'm sorting the input array, because the input array can be, it is not sorted. Then I have taken an result array which we are going to return later once we find the result. Then what I'm doing, I'm a loop over each of the elements of the numbers array, and then what I'm going to do, I'm going to calculate the target which we have to search. So what we will do is we'll take the ith element and then subtract target from it. So for example, our ith element with I is equals to 0 iteration, our ith element on the numbers array would be 2, and our target would be, target that we got as an input is 22, right? So we'll compute the target to search, and the target to search would be 2 minus 22, that is minus 20. Then we are taking the absolute value of it, so the minus would become positive. Now what we will do is we will do a binary search implementation on this array. We'll provide it the starting index and the ending index. Then we'll also provide it the target to search. So we have to search 20. So the logic here is basically, if if you remember, we have to find two elements that sums up to the target. So if we subtract the current element from the target, we will, and then we will search for that other element. Numbers of 0th element is 2 and our target to search is 20. So in this numbers array, we will search if 20 is present. No, 20 is not present. Then we will go to the next element. Now the next iteration would be for I is equals to 1. For I is equals to 1, the number is 7. So now what we will do is we will search for 22 minus 7, that is 15. Now we will search, is 15 in the array? The answer is yes. 15 is in the array and it is at the third index. So the answer here would be 1. At the first index we have 7 and at the third index we have 15. So 7 and 15 adds up to 22. So we have the answer here. Let me execute it in the execute anonymous window. So I'm currently in my execute anonymous window, and if I show you the binary search implementation as well, this is what we have done in our previous implementations. So by now you should be able to understand it very clearly. And let me go to the execute anonymous window and let me run this code. So we have the answer here should be 1 and 3. Let me click on execute highlighted, debug only. Answer is 1 and 3. Now let me change the target. Let me change the target to 13. So now I have changed the target to 13. That means our answer should be 0 and 2, because if we add 2 and 11, it ends up giving us 13. So let us see if our code is working correctly. Boom, 0 and 2. That means our code is working correctly, and we have fully solved the two sum problem in Apex. Now there is another problem that I want to solve, that is also a classical problem, that is the three sum problem. Given an integer array nums, return all the triplets such that I is not equal to j, I is not equal to k, and j is not equal to k, and nums of I plus nums of j plus nums of k is equal to 0. So we have to return all the triplets here where I, j and k are not the same index or not the same values, and when we sum up their actual array elements, we get 0. And let's see an example once. So this is our array, which is -1 0 1 2 -1 -4. We have two triplets here, and if we look at the explanation here, right, so we have three triplets that are different, and that adds up to 0. You can see the first triplet is nums of 0, nums of 1, and nums of 2, which is -1 0 1, and the answer here is 0. So this is one of our value. The second triplet here is 1 2 and 3, which is 0 1 -1, that also ends up to 0. And the third one is 0 3 and 4, 0 3 and 4, which is -1 2 -1, that also ends up to 0. And they are saying that the distinct, we only need to have distinct triplets, and it is the values here are -1 0 and 1, and -1 -1 and 2. And they are also telling us that the order of the output does not matter. Only thing here is I, j and k should not be equal, and I plus j plus k should be equal to 0. So I've coded the solution in Apex. Let us go through it and try to understand what is happening in the code. As you know, we need a list of list. So I've created a result list, which is basically a list of integers, right? And then we are checking if the size of the nums array, the input array, is less than equal to 2, because since we need to make a list of triplets. So if the size is less than 2, just return the empty array. Now from here, we need to have the array as sorted, because could be the array is not sorted. To perform the binary search, this is a prerequisite that the array should be sorted. So we'll loop over the elements of the input array, right? Then we have one condition where if I is greater than 0 and nums of I is equal to its previous element. So if you remember, the condition here was I should not be equal to k and k should not be equal to j. So the three indexes should be distinct. For that, we are adding this check if I is greater than 0 and nums of I is equal to the previous element. Just skip that iteration, right? Now the next line, we are taking the left as I plus 1. Let's say I is equal to 0. Left would be I plus 1, that is 1, and the right would be the last index. Here we are performing the binary search. So we want to this is the three sum integer. So we will take the sum of I, left, and right. These three elements, I is the 0th element, left is the next element, I plus 1, and the right is the last element. We'll take the sum of it, and then we will check if the three sum is greater than 0. So if it is greater than 0, we will subtract we will do right minus equal to 1. That is, we will move the right pointer to one step backward, because the array is sorted. Since the array is sorted, and the three sum is greater than 0, and we want a triplet that sums up to 0. As we read in the question, we want a triplet that sums up to 0. So that is why we will make the right pointer, we will decrease the right pointer by 1. Else if three sum is less than 0, That means we have to increase the value. So we'll move our left pointer by 1 so that the value could be increased. And if the condition, if these two conditions both are false, that means 3 sum is equal to 0. That means we have got our answer. Now what we will do, we will add the triplet new list of integer to the result array, and then we will move the left pointer by 1. So you know the binary search, right? In the binary search, our left should be less than right. So if to move to the next iteration in the binary search, we'll always move our left by 1. So after we add the result, we'll move our left pointer by 1. Then we are checking while nums of left is equal to nums of left minus 1. That means whether the next value is equal to the previous value. Nums of left is equal to nums of left minus 1. That is because if nums of left is equal to nums of left minus 1, then it makes no sense to do the binary search again, right? Because it would be the same value and it will give us the same iteration. So what we will do is we'll add this check if nums of left is equal to nums of left minus 1 and left is less than right, because this is the main condition for the binary search. And if both these conditions are true, we will move the left pointer by 1 till the left pointer does not equal to its previous value. So hope that makes sense here. After that we will just return the result, that is our output result. So let's this was all the code for the 3-sum solution. Now let me execute it. Let me go to the execute anonymous window. Let me give this example array. So if I go to the Leetcode screen, this is the same array and the answer here is -1, -1, 2 and -1, 0, 1. So let's see if we get the same answer. Execute highlighted, and if I do this, -1, -1, 2 and -1, 0, 1, boom, the answer is the same. So let me do one, move two values from this array and let's execute it and see what would be the answer. So I can only see one answer here, that is -1, 0 and 1, because if we add these three triplets, we'll get 0. And apart from that, I don't see any other value. So the answer here should be -1, 0 and 1. So let me execute it and let's check whether the answer is correct. Boom, the answer is correct. So in this video we have solved both the 2-sum and the 3-sum problems using the binary search algorithm. Thanks everyone for watching till the end. Hope you like this. Do subscribe to my channel for more such videos where you want me to solve Leetcode questions using Apex programming language. Thanks everyone.